This video is a third in a series of videos on transformations, this time focusing on rotations. A rotation is just a transformation that turns a figure, a pre-image, about a point that we call the center of rotation. It's a weird way of saying things. We say about a fixed point. We really mean around that fixed point. I don't know why we say about. And again, that center of rotation is just that point. So in this picture here, my center of rotation is point P. And here I am, I pick a point and I measure how far away that is. Then I'm going to take this line, and in this case, I rotate it 90 degrees. And that's how I know where to put the image point, the transformed point. Rays drawn from that center of rotation to a point and its image form the angle of rotation. Right here, that would be the angle of rotation. In this case, I'm rotating 90 degrees. These are also isometries, kind of like the translations and the reflections were, if you've seen those videos. All that means is the pre-image and the image will be congruent to each other, just flipped around a little bit. To kind of understand rotations and angle rotations, we need to understand what we mean by a positive rotation versus a negative rotation. So I've got a figure here, that's my pre-image, and let's say I want to rotate it in a positive direction. Well, positive directions are when we go this way, and we call that being counterclockwise, because that's counter or opposite to how a clock goes. If I was to rotate that pre-image 45 degrees, it might look like this. And all that means is that if you have a point of rotation here, and let's say I'm looking at the tip of the tail, it means that tip of tail to tip of tail will be a positive 45 degrees. And positive, again, is this direction. Well, what if I wanted to rotate this in a negative direction? This is the negative direction. And there is my image being rotated a negative 90. If I do the same thing by looking at the tail points, this point, and I don't know, let's say that was my center of rotation or point of rotation, then that would be negative 90. So I started from here and I went that way. And let's say I wanted to go to this same location, but I want to go in a positive direction. So that would be rotating 3/4 of the way around. And since circles are 360 degrees, 3/4 of the way around would be 270 degrees. So going negative 90 rotation and a 270 degree positive rotation will get you to the same place. So if you don't want to worry about negatives, you can sort of turn them into positives as well. And this sounds a little confusing, but I just wanted to point it out. So if you see positive or negative rotation values, you can rotate around any point of rotation and you can rotate any number of degrees. To make things a little bit simpler for us, we're only going to rotate 3 possible ways. So you can go 90 degrees, you can go 180 degrees, or 270. Remembering that 270 is the same as negative 90. Now, you can go 180 in a negative direction. It would be negative 180, because if you're going halfway, you can go this way or you can go that way, but you're going to get into that same spot. So those are the ones we're going to be worried about or concentrating on for what we're doing. And our point of rotation will always be the origin at 0, 0. It makes things a lot easier. We have a bunch of rules, and we do have to remember these rules. So if you are rotating 90 degrees, you start with your pre-image point, then you reverse their order, and then the first value in your image, that coordinate becomes opposite. I'm not going to say negative because sometimes that's confusing. It's just opposite to whatever this one was. So if this was a positive value, it becomes negative. If over here in our pre-image that was a negative value, it would be positive over here. So swap the coordinates and then make the first one opposite. Now 180, we've actually seen this in a previous video. If you haven't seen the reflection video yet, you can take a look there because there's something called a point reflection. And it is exactly the same as this. Point reflections are the same as rotating 180 degrees. Your X and the Y in your image stay in the same location. X is still the first one and Y is still the second one, but they become opposite values, both of them. And if you're doing a 270 degree rotation, or again, a negative 90 rotation, you are going to change the order just like you did for the 90, except this time, the second coordinate becomes opposite. And this is very confusing and it has to be remembered. And you're just going to have to do the best you can. I can only tell you how I remember them. And it's not a good way, and I'm sure there are better ways. I think of my coordinate plane, and to remember our quadrants, and I only use this little trick to remember the signs. I have to just get it straight in my head that 90 and 270, you're going to turn the Y and the X. So they are going to change positions, and they're not going to change positions with the 180. So I think I can sort of remember that. It's just the signs that mess me up. So here's what I do, and I'm sorry if this is confusing because I bet it will be. But let's say I've got a figure over in quadrant 1. So in my mind, if I think about what that looks like to rotate something about the origin 90 degrees, I'm going to get something in the second one, the second quadrant. And how does the second quadrant work? Your first coordinate is negative and your second coordinate is positive. So here is a first coordinate negative and a second coordinate positive. If I was to rotate, say, a figure from quadrant 1, 180 degrees, it would turn it upside down and it would wind up in quadrant 3, where the X is negative and the Y is negative. So that's why I have a negative and a negative. And if I was to take this thing in quadrant 1 and go 3/4 of the way around, I would wind up in quadrant 4, where my first coordinate is positive and my second coordinate is negative. First coordinate positive, second coordinate negative. I'm willing to bet that for most of you that made no sense whatsoever, and I apologize. This is how I remember it. You may want to try watching it again to see if you can make sense of it. If you can't, that's perfectly fine. You don't have to remember this little way of remembering things, but you do have to remember what happens to get a 90-degree rotation, what that mapping looks like, what the mapping looks like for 180, and what it looks like for 270. So you may have to find your own way to remember it. All right, let's do an example here. So we're going to graph quadrilateral RSTU, and we've got some vertices. So let's go ahead and graph that. Here's my quadrilateral, my pre-image. And what they want is to rotate this quadrilateral 270 degrees about the origin. And again, that about just means around the origin. So it's like I took a pole and I started R, and I'm going to go 3/4 of the way around. Where's that going to wind up? Same thing with all the other points. Write the rule down. It's really important for these because they are so easy to forget. If you have it written down right in front of you, it lets your brain be free to do other things. So for a 270-degree rotation, I know that the X and Y are going to switch order. I know it's not going to stay like this, though, because this is actually the mapping for reflecting over the line Y equals X. So 270, the first one is positive and the second one is negative. That will be the mapping, and it is very important. I have to only think about this one time, and I've written it down, because now when I do my mapping, I just want to make sure I'm doing it right. I wrote down the RSTU, the pre-image points over in this column. Let's see what happens for R prime. So this says switch the order. So instead of 3, 1, it's 1, 3. And now the new second coordinate is opposite. For this one, switch the order, and the second coordinate will be opposite. When they start having negatives in there, it can be a little confusing. So I'm switching the order, and then the second coordinate becomes opposite. Switch the order, and second one becomes opposite. It's even more confusing if this second one originally was a negative, say, then you have to make it positive. But if you're careful when you do that, you go and you graph the image, you should see something that looks like it's 3/4 turned around that origin. Let's graph. And then if we just take a look here, get rid of that little mark. It does look like that purple figure rotated 3/4 of the way around. I always do that visual check because very easy to make mistakes. Okay, now it's up to you to do these U-tries, and there are a few of them here. So we're rotating this one 90 degrees about the origin, and we're graphing, 3 of them, 90, 180, and 270 rotations on that one. So there's 3 in that one question. And then this one is just a can you figure it out sort of thing. So I'm showing them all in advance in case you don't have a copy of the paper that is available to my students, but you still want to try them. So go ahead and pause the video, pause it now, and then when you're done, come back and see how you did. So we're back. We want to rotate the quadrilateral JKLM 90 degrees about the origin. Why don't we go ahead and just graph the pre-image. Have this quadrilateral, and it's going to be 90 degrees about the origin. So that's a quarter turn. We want to write the rule down. So XY. So that one will, again, it will swap the X and the Y values one after the other. And then the first one becomes opposite, that new first one. Let's write these points down. It is important, I think, to write them down just to keep it all straight. So we're going to change the order. We're starting at 1, 4, so that becomes 4, 1. And then we change that sign. K is 5, 5. So since it's the same, swapping them doesn't look any different, but you want to make the first one negative or opposite. L prime, swap the order, make the first one opposite, and M is also the same number twice, and then make that first one opposite. And then we're going to go ahead and graph our image points, and then it should look like we did a quarter turn going in that direction, and it kind of looks like that to me. Okay, there's a lot going on with this second one because there's 3 different ones in the same image. So let's carefully do just the pre-image, this one. First, we're going to rotate it 90 degrees, which makes it a quarter turn, then 180, which is a half turn, and then 270, which is a 3/4 turn again. And we're turning in this direction, counterclockwise positive. Let's see, we got to be super careful here. Let's start with the 90 degrees. And I'm going to write the rule for 90 degrees. It's XY. You change the order of the XY. First one becomes negative. My A prime there will be 2, 3, switch the order and make the first one negative. 2, negative 1, switch them. And make the first one opposite. So if this was negative, that now becomes a positive. C prime, negative 1, negative 1. So switching the order doesn't look different, but the first one becomes opposite. So that should be our quarter turn, and let's see what that looks like. And that should be my quarter turn. So you have to picture that black figure turning to the left, a quarter turn. So that's 90. Let's do a different color for the 180 degrees. And that mapping is XY. Does not change the order, but they both become negative. I can't stress enough how important it is to actually write this down so you're looking at it. And I'm going to call this one a double prime so that we don't confuse it with the other one. So I'm just going to look at 2, 3. Everything stays the same except for opposite sides. B is 2, negative 1. Just change the signs. And C prime 1, 1. And let's graph that. This should look like the black figure upside down. That's this. You have to be real good at seeing things here. So this black ABC, if you turn it upside down, you get that red figure. And let's do the final one, 270. So that mapping is XY. You're going to switch the order, but this time it's the second coordinate that will become opposite. So I'll make this with 3 little primes. A prime, so 2, 3, you're going to switch the order. But now it's the second coordinate that becomes opposite. So switch the order, it's negative 1, and then instead of 2, I'm going to make it opposite. Switch negative 1, negative 1. So that's not going to look any different until I switch the sign, and it's the second one. Let's graph that. Again, critical things here are writing down the rules and writing down the new points. But in that mess somewhere, I think we have the right answer. And then this one, it's just to see if we kind of understand how this works with the rotational things. What are the number of degrees separating the fan blades? My center of rotation is in the middle here, and I'm going to pick the same point on 2 blades. So I'm going to pick this left point, and then I'm going to pick the left point on another blade. Go to the center. Go to the center. That's 90 degrees. We have 4 of these blades. They're going to be 90 degrees apart. Kind of makes sense because that is 360 degrees. This is a little bit of a precursor to what we're going to be doing when we look at symmetry. So you can just get a little sneak preview there. And if you want, you can go check out the symmetry video. But other than that, that is all I have to say about rotations. Thank you for watching.